So as a continuation of what we talked about yesterday, we did the entire chapter. So if you need to go back and watch the video or go back and read the chapter, you can. We're going to go through just problem after problem today, so that shouldn't be a big deal. So hopefully you'll kind of get the gist of what's going on. So the first two questions are just about random numbers, that kind of thing. So number one, is a coin flip random? Why or why not? So is a coin flip really random? Yes, a coin flip is a truly random event. A truly random event cannot be predicted, right? In an equation. It's truly random. Because the outcome Right. Number three. Many states run lotteries, giving away millions of dollars if you match a certain set of winning numbers. How are those numbers determined, and do you think this method guarantees randomness? Explain. So if you're thinking about like the Powerball or like the big state lotteries, right? How do they come up with those numbers? Right, those balls, right? They have like the popcorn thing, and they're like all like the balls are running around, and they like go out the little chute, right? So, do you think that is random? That should be random if it's done that way. And then we already said that it guarantees random. So it's equally likely to get shot out little air bubble stuff, right? I don't know what it's called. What's that called? Air bubble stuff. All right. So make sure you're thinking about bird. Okay. The rest of the, not the rest of the, but next few examples are going to be doing pieces of simulations, but not a whole one. Okay? So number 5, the American College of Obstetricians and Gynecologists say that out of every 100 babies born in the United States, 3 have some kind of major birth defect. How would you assign random numbers to conduct a simulation based on this statistic? So how would you do the random numbers in this scenario? All right, we could assign 0 through 2 to what? Right? Babies born, that's not how you spell born. With birth defects. And then what would you do with the rest of the numbers? So since we're going to use up to 99, right, you have to use double digits. So 0, 3 to 99. Again, I don't know why I can't spell born. All right, so make sure when you start a problem, you might be using single digits because you're thinking out 0 through 2, but if you have to do all the way and you're using double digits, you're going to have to make everything double digits. That's not as important when you're using your calculator, but it's super important when you're using a random number table, which is generally what you're going to have on an AP exam. Questions on that one? Okay. All right, so number 7. An elementary school teacher with 25 students plans to have each of them make a poster about 2 different states. The teacher first numbers the states in alphabetical order from 1 to 50, and then uses a random number table to decide which state each kid gets. Here are the random digits. All right. So which 2 state numbers does the first student get? So you're going to start all the way at the left, right? So we're looking at 1-digit numbers or 2-digit numbers? 2. So the first number is 45. Does that correspond with a state? Yes. So, and it just asks for the numbers, doesn't ask for the state. So you have to figure it out. It's fine. 45. The next number is 92. Does that correspond to a state? No, because we're going from 1 to 50, right? The next one is 10. So the first student would get 45 and 10, this as the state numbers. And then they'll go back to the little chart and figure out which states those are. Okay? Which two state numbers go to the second student? So you pick up where you left off, right? So does 17 correspond to a state number? So 17. The next number is 10. We already used 10, right? And it says that each student's getting two different states, so we're going to have to skip over 10. And the next one is 22. Questions about using those random digits? Okay. Number 8. Your state's big bucks lottery prize has reached $100 million, and you decide to play. You have to pick 5 numbers between 1 and 60, and you'll win if your numbers match those drawn by the state. You decide to pick your lucky numbers using a random number table. Which numbers do you play based on these random digits? So when I'm going across my digits, what am I looking for? Double digits, single digits, double digits, and they have to be between what numbers? 1 and 60, so if not, you skip it, right? So 43 is my first one. Am I going to pick that one? What about 68? What about 9? Okay, 87. 50. I'm picking 6 numbers? It's 5 numbers. 5 numbers. Okay. I've got 1, 2, 3 numbers so far, right? 13. 9. Didn't we already use 9? Can you use it again? Okay, so if we can use it again, we use 9 again. If it has to be 5 different numbers, then we would use 27, right? It didn't specify in the question. Well, because different state lotteries do different things, right? Some state lotteries, it's just whatever numbers come, multiple different numbers, the same thing. And some are different, you can only have 1. So it didn't specify in this question. All right, questions about 8. Here's a random number table because here, calculator too quickly. And so then on quizzes and on free response questions, I had my AP students like they're messing up using the numbers. So I'm just making sure we know what we're talking about. Okay? All right. 11 and 13 are just talking about what's wrong with the simulation and what's wrong with the conclusion. If you know what things are wrong, then you're less likely to make those mistakes. After that, we'll actually get into So explain why each of the following simulations fails to model the real situation properly. All right? So part A, use a random integer from 0 through 9 to represent the number of heads when 9 coins are tossed. Right, you're looking for the number of heads, right? Each trial flip, right? So what numbers would you use if you just have a coin flip? 2. You only use 2 numbers, right? One that has heads and one that has tails, right? There's no reason to have more numbers. Likely, or you have 2. So you do not want to use 0 through 9. You want to use 2 numbers to represent heads and tails. And then you would do 9 trials, right? 1 number each. Probably 0 and 1 or something. Does that make sense? Again, make sure you're modeling what's actually happening, not what you just have numbers that match up. On B, a basketball player takes a foul shot. Look at a random digit using an odd digit to represent a good shot and an even digit to represent a miss. What is the assumption here if they're saying odd is a good shot, or yeah, odd's a good shot and even's a miss? That's assuming that the basketball player has a 50-50 shot of getting the foul shot, right? Do most basketball players have a 50-50 shot? Most of them are either. So if you're a basketball player, you're going to keep track. Hopefully you're like an 80% foul shot shoot, like, percent. If not, maybe you're 20%. You need to know what percent of the time they make these shots to assign those digits, right? You can't just assume it's 50-50 unless I told you it was 50-50. Okay, does that make sense? So we would need more info. About how often the shot is made. All right, use random digits from 1 through 13 to represent the denominations of the cards in a 5-card poker hand. That's saying like 1 being an ace, and then 2 being a 2, and so on and so forth. That's what's saying. It says denominations. So what is wrong with that? Okay, let's say this happens. All right, this is going to happen. Right, I'm going to use these digits to do 5 times, right, to do 5-card hand, right? Let's say I get a 5, and then a 5, and then a 5, and a 5, and a 5. You only have 4 5s, right? Okay, so you can't just, there might be an extra layer to this problem, right? You can't just do 1 through 13 5 times in a row, because then you might have other cards that don't exist. Okay? There's only 4 of each denomination. So that's going to be tricky. All right, 13. The stats student properly simulated the length of checkout lines in a grocery store and then reported. The average length of the line will be 3.2 people. What's wrong with that conclusion? She did everything right, so what's wrong with what she said? There's one word that makes this bad. Will. Remember in statistics, we don't ever guarantee anything is happening, ever. We can say, I mean, you can say it could be about 3.2 people, but it's not going to be 3.2 people, right? Yeah. So I can see a problem with the 3.2, but there's a big problem with the will be happening. That's all we say about should be, could be. We don't ever say this is going to happen. This has come up in like a million chapters now, right? Don't use the word so. All right. The rest of my examples are either setting up pieces of simulations or doing entire simulations. Okay? So the pieces ones will be a good reminder of what we did yesterday, and the simulations will be good to set everything up. And I'll show you how to use your calculator. Okay? I don't want to start with that. I guess I have to. Okay, here we go. I picked this one specifically because it's a little more complex than we did yesterday. And instead of giving it to you for a homework question and you guys all freaking out, I'll give you an easier one for a homework question. Okay? So when drawing 5 cards randomly from a deck, which is more likely, 2 pairs or 3 of a kind? A pair is exactly 2 of the same denomination, and 3 of a kind is exactly 3 of the same denomination, if you didn't know that already. Don't count 3/8 as a pair, that's 3 of a kind, and don't count 4 of the same kind as 2 pair, that's 4 of a kind, so a different hand. How could you simulate 5-card hands? Be careful, once you've picked the 8 of spades, you can't get it again in that hand. So you have to be really specific. So I'm going to walk you through this one. But you should be able to answer some of these questions. All right? In part A, what is going to be a component? 1 card. So a component is selecting 1 card. Remember, it's a building block. It's the building block of each trial. One card, right? We're going to skip to C for a second. What's the response variable? What are we trying to figure out? What's the question being asked? Right, we're trying to figure out if it is more likely to get, this is C, to get 2 pairs or 3 of a kind. All right, so let's go back to part B. And this is where it's a little, we're going to use ideas we talked about yesterday, but this one's going to be kind of a layered type question. So we need to describe how you're going to simulate a trial, right? So we know that each trial is going to have how many components? 5, right? It's a 5-card hand, right? So you have to have 5 cards. But it's going to be more difficult when you're picking your cards, all right? It just told us up here that be careful. You have the 8 of spades. You can't have their 8 of spades. They're being very specific in this problem. It's going to matter the denomination and the suit. So because of that, you're going to have 2 digits to represent each card. All right? If you have 2 digits to represent each card, then what are you going to do for one versus the other? Well, so you need to, for part B, you're going to need to assign digits to represent a suit, right? So maybe 1 is diamonds, and 2 is hearts, and 3 is clubs, and 4 is spades, or whatever. We're not doing the simulation, so you don't have to worry about it. We're going to assign 4 digits to represent a suit. So you're going to every time have to generate a number first of the suit you're looking at. And then on top of that, so you're representing each suit. So 1 digit per suit. And then you have to assign digits to each card type. So maybe 1 is an ace, and 2, 3, 4, 5, 6, 7, 8, 9, 10 are the number cards, and 11, 12, and 13 are jack, queen, king, whatever. But you're going to have to assign numbers to the actual cards as well. So when we're doing a trial, each component is not going to be one number, right? We're going to have to generate 2 numbers to represent a card. And do this 5 times to represent a hand. And then no card can be repeated. Right? That's a little more complex than what we talked about yesterday. Well, you could do that. If you need 2 different things to keep track of something, you can do that. And then you would do that 10, 20, however many times you need to do that. Does that make sense? Would you be able to do it on your own? Probably not. Not the first time, at least. Right? We didn't talk about that yesterday. Okay? All right. The rest of my examples are simulations that we did yesterday. We're going to write it out. We're going to actually do the simulation, and then we're going to give a conclusion. Okay? So the first one is about cereal boxes like we talked about yesterday, and then we have a different one that's about multiple choice tests. So, in the chapter's example, 20% of the cereal boxes contained a picture of Tiger Woods, 30% David Beckham, and the rest Serena Williams. We did this yesterday, but this is going to ask us to do something different. Suppose you buy 5 boxes of cereal. Estimate the probability that you end up with a complete set of the pictures. Your simulation should have at least 20 runs. Okay, so this is not asking us to do the same thing as we did yesterday. Yesterday, we're trying to figure out the typical number of boxes you have to buy to get a complete set of cards. This one's saying you buy 5 boxes. How often are you actually going to get a complete set? All right, it's a little bit different. So we need to set this up. There are 4 things you should have. It's pretty much 4 sentences in the setup of your problem. What's the first sentence you have? Right, you always want to define the component first. I'll write the steps to the side. So in this case, what is a component? Right, so a component of the simulation is material. After you've assigned or defined the component, what's the next thing? You can do the response. I'm going to do the response at the end. I'm going to assign numbers. Since I know what a component is, I can assign numbers to those components. So are my numbers going to be anything different than what we did yesterday? No, because we're still just doing one cereal box at a time, right? We want to know what card is inside the cereal box, right? So I will assign 0 through 1 to boxes with Tiger Woods cards. Uh, 2 through 4 to boxes with David Beckham cards. And 5 through 9 to Serena Williams cards. So we did that yesterday because we have percentages that are multiples of 10%, right? So my digits should represent the same percentages. So I have 10 digits. 20% is 2 digits, so 0 and 1. 30% is 3 digits, 2, 3, 4. And 50% is 5 digits. You don't have to, but if you go 1 through 10, you have to use 0, 1, 0, 2, because you're doing double digits then. Someone asked me yesterday in a different class if it was acceptable, instead of using 0 through 9, to use 00 through 99. Sure, that's fine. You split them up 20%, so instead of having 2 numbers, you'd have 20 numbers, 30 numbers, and 50 numbers. That works too, as long as it mimics the percentages given in the problem. After you've assigned numbers, what should you do? Right, set up the trial. So what would a trial look like? So for each trial, I will generate 5 digits to represent the 5 boxes of cereal. So yesterday that was different. Yesterday we were trying to do boxes until we got all 3 cards. So I had to generate numbers until I had each different playing card, right? All right, so then after we define a trial or describe a trial, what's the last thing we should do before we run the simulation? Response variable. So I am interested in the probability of getting all 3 cards in the 5 boxes. Okay, now I actually have to run the simulation. I'm going to show you how to use your calculator because that will expedite this process. You could use random numbers from the table on page 873. And in fact, those are in groups of 5 anyway. So that's nice, right? Because there's spaces. So you could still use that too. You don't have to use a calculator. But this is a great example of how to use the calculator, okay? Okay, on the calculator, if you want to use random integers from your calculator, you go to, well, let me not draw on it. You go to Math, you scroll over to Probability, the last one, and you go down to number 5 where it says rand int, because we want a random integer. In the parentheses, you put the lowest number you want, comma, the highest number you want. Okay? So in this case, we're using 0 through 9. I'm not going to do the simulation yet, but we want 0 through 9. So you can do 0, comma, 9. And you would enter, and it gives you a number. And if you don't have to keep typing in, you just keep hitting enter, and it'll keep giving you numbers. Okay? The comma is right above the 7. If you have never used it, then you and your friends will have the same numbers. It doesn't really, eventually you're going to get, if you just do a few and someone else has a few more, then eventually you'll get off and it's not a big deal. Okay? So, questions about how that works. Now you can take this a step further. For our simulation, for example, we want 5 numbers. Yes? So I can go back to math, probability, go back down to 5, and I can put in my lowest number. Well, 1 second. I can go and do the lowest number, comma, the highest number, comma, how many numbers I want at a time. So in this case, I want 5 cereal boxes, so I want 5 numbers. So it'll give me a list of 5 numbers. And you keep hitting enter, you get more 5 numbers. Now, I put a caution at the bottom of your page. All right? Let's say I have to do a list of 10 numbers. Okay? Let's say I want a list of 10 numbers. So I want to do 0 through 9, but I want 10 numbers. They're going to go off your page. All right? If you press anything besides the right arrow key, you won't be able to see the rest of your numbers. So right now it has a nice little arrow to the right, and I can press the little right arrow and it shows them fine. Okay? But if I hit like the times button or something, and I go back up here, it won't let me move it anymore. Because the calculator hates you. So just keep that in mind. Okay? So you have to, if you press anything at all, by accident or not, if you don't press the right arrow immediately after you do it, you won't be able to see all the numbers. So you cannot go back up and look at them later. So you can't do like 5 trials and then go back and look at all of them. It won't let you. If you're doing like 5 numbers at a time, 6 numbers at a time, normally you're okay. But you get to like 7 and 8 numbers at a time, you have to start scrolling, and that gets more difficult. So maybe if you want 10 numbers, you do 5, and you just do it twice or something. I'm just trying to make sure you don't get mad on your homework or something because you're trying to do 15 numbers at a time and you can't ever get to them. Okay? All right. So let's do the actual simulation here. All right? We're going to do 20 trials. So if you're doing 20 trials by hand, that might take a while. If you're doing it on the calculator, it's still going to take a little bit, but maybe not as much work, right? It's all personal preference. You don't have to use a calculator. You can use the number table if you want. I'm probably just going to do 10 trials for the sake of time right now, but it was a homework problem. It says to do 20, so you do 20. I'm going to write not all of the outcomes. You could. Right. So you could write all the outcomes down. If you could do like, okay, that was a Serena, David, Tiger, Serena, if you wanted to. I'm not going to do that for the sake of time. I'm just going to write, yes or no? Did we get all 3 cards? That's all I'm really interested in, right? Okay, so math probability. 0 through 9, and I went 5 of them. So I get a 7, a 3, a 2, and a 9. Does that connect 3 cards? No, because I'm missing a 0 or a 1 to be the tiger card, right? And so I do it again. So in trial 2, do I get all 3 cards? No, I don't get a David Beckham card. There's no 2 through 4. Oh, well. So this time I get 3, 0, 9, 1, 3. Is that all of them? I'm going to do another one. 1, 2, 8, 3, 5. Yes. Right, if you're doing it with your calculator, you're going to have different. 60006. No. 78314. I'll do 7, and I'm going to do 8, 9, 10 over here, so I'm going to scroll down. 9, 6, 5, 9. 6, 7, 5, 3, 2. 6, 8, 1, 4, 4. 2, 8, 9, 4, 4. All right, so you would do that 20 times in your homework. Okay, I'm only doing 10 to save us some time. All right, so after you do the trials and you keep track, we have to go out and give some sort of conclusion, right? I was trying to figure out the probability of getting all 3 of the cards if I boxes. So again, if you did different number, like you did your calculator, you might get different numbers, you might get a different result. Like everyone in this class, different result depending what random numbers you're looking at. Okay? In my simulation, so in this simulation, I would get a complete set of cards. 1, 2, 3, nope, 4. 1, 2, 3, 4 out of 10 times, which is 40% of the time. On the one I did back in the day on the homework, I did the 20 trials and I got 8 out of 20, which is also 40%. So I've hit 40% twice. Maybe you hit 30, maybe you hit 60, 80%. So it all depends on what you have. That's why I talk about your simulation specifically, not what's happening every single time. You don't say this is going to happen. Does that make sense? Yes? Yes? Okay. I'm going to do one more problem because so far every single simulation we've done pretty much has been serial related. So I've got one more, and then I'll let you start working on your assignment. Your assignment that I haven't given you yet. All right, here we go. You take a quiz with 6 multiple choice questions. After you studied, you estimated that you would have about an 80% chance of getting any individual question right. What are your chances of getting them all right? Use at least 20 trials. So, in this problem, what is a component? Right. Is one question outcome. So did you get it right or did you get it wrong? Right? After I defined a component, we go back there and we're going to assign numbers. Now, we're assigning numbers. We're interested in if you got the question right or not, right? So what am I going to do for assigning numbers here? Good. I will assign 0 through 7 to answering the question correctly. And then 8 through 9 to answering the question wrong. So what is a trial going to look like? So for each trial, I will generate 6 digits to represent the quiz, right? To see how many times I get them right or wrong of your 6 questions. And so what are you interested in? Right, the response variable is the probability of getting 100%, right? Of getting them all right. So again, it says do 20 trials. I'm going to save this time and do 10. So trial number, and then yes or no, you got 100% or not, right? So I'm using number 0 to 9 again, and I'm using 6 digits. So 8 and 9 is if I get them wrong. So I did not get all right. Trial number. I was just trying to save time. So 8s and 9s mean I got them wrong. So I did not get all of those right either. And so on and so forth, right? I would do that. I did this and got, so after I did mine earlier, my simulation from before, I got a 100% 7 out of 20 times. So maybe you get 40%, maybe you get 60%. It depends on your simulation. When I'm looking at your homework, I expect to see, for a simulation, that paragraph at the top, those 4 sentences. I expect to see some sort of way you kept track of your trials, and then some sentence of conclusion that answers the question they asked initially. Okay? You don't have to. You have some sort of table somehow that you did.